Hi, my name's John. Welcome to another Sunday night nightcap. In tonight's nightcap, I modify an inlet manifold of a track car. I cut a flange off and weld a flange on so it'll take a different throttle body. I'll show a bit of that, and there's actually some nice clear welding arc shots for a change. I managed to turn the camera on before I started welding. In part 2, I do a repair on my Harrison lathe. I mentioned last week that I was going to do a talk at a local technical college. The talk went ahead. I took one of my steam engines down and ran that off a compressor. I'll be the first one to admit that I was very nervous before I started. I haven't spoken to large groups of people before. I normally speak to a camera. It's different when there's lots of little faces looking at you and not knowing quite what to expect. Anyway, they were very, very good. They sat there intently listening. I don't know if they've been told to or not, but they certainly seem to enjoy themselves. Most of them have subscribed to my channel, and I'm sure one or two are watching this now. If you are watching, once again, thanks very much for listening to us and making us feel so welcome. I've got an inlet manifold here. It's off a, I believe, a Rover car, a 2 litre turbo petrol. And what the lad wants to do is use a different throttle body on it. So it's been modified once before, and then once modified again. So I need to make a flange out of that piece of aluminium plate. Chop all that off and then weld the flange onto there. And he wants to make it so that the goes like that, so the throttle cable is at the top. So the first thing I do is weight the aluminium flange and then cut that off, probably angle grinder or a hacksaw, I'm not sure, it's not that thick, probably just a hacksaw. Then I can mill it flat, take all the paint off and all this scabby weld, and see if I can put a scabby weld on. I'm going to use a transfer punch to put the 4 bolts in, sort of centralise it. Don't think it moved. Okay, so we've got those 4, and that bore is in the centre of the 4. So we'll simply join these up. That gives us the centre of the plate. And the hole needs to be 60mm. I'll drill the holes there first. They'll be 5mm because it's a 6mm bolt. Drill and tap those, and then we'll mount it in the lathe and bore that centre hole out. I need to tap those holes 6mm. It's nice to have them nice and straight. I could have done it in the milling machine, but what I have got is a little piece of case steel here with a hole in. It's a nice fit on that tap. That one's for a 5, that one's for an 8. That simply goes into there, started in the hole, and if we clamp that in the vise like that, we can put the tap straight through, and that's going to act as a guide. Keep it nice and straight. A nice new tap. As quick as that. Quite a handy little jig, very easy to make. We'll do all 4. lad's drill just to de-rag the holes. Right, so that fits on there quite nicely. Transfer punches are great for this sort of work. I now need to bore that hole out in the centre to 60mm. I've put 2 of those really strong rare earth magnets on there. There used to be one where I broke it in half accidentally. You've got to be careful with these bastard things because they really are strong and they want to hurt you. All that for is spacers to space that away from the chuck face so I can bore all the way through, and I simply bring the steady in and push that against those, and that's going to keep it reasonably well lined up while we nip up the, what I mean about the bastards, I really are potent little magnets. Right, so if we can just nip these jaws up now, it's going to hold it in place. And we'll put a little nip on them and we'll put a clock gauge on and see how far away we've got it. It normally works out pretty well doing it this way. Easier than trying to hold it and drop things in it. And right, so all I do, I've shown this plenty of times, is put another centre in there, bring a tailstock centre into that one, clock gauge goes onto there, that goes in and touches the centre. The nearest you can get it to the end, the more accurate it'll be, and that's within 5 or 6 thou straight away. Right, so all we do is find the highest point, which is that one, nip that jaw up, highest point again, that one, that one, you can either leave the magnets in or leave them out. They aren't going to go anywhere. I've done this quite a lot, but it's entirely up to you. And you certainly don't want to be standing in a line of fire with it if you do leave them in. All I want to do is get the metal out of here as quickly as possible. Got an 1.5 inch drill, which will give it a good start. Not present stuck at all this. Actually sticking to the tip, that's what's causing the problems. We'll put a new tip in there. The next new tip, you can see it makes a massive difference. 50mm, 60mm. Dead on 60. Right, John's happy with that. Nice finish as well. It's set up a little bit on the sketchy side, but I'm sure it will do just to square the end of that face up. I've got it mounted on 2 parallels, and that's the longest miller cutter I've got. Last bit I can just do by hand with a file. Should be able to get it actually. Just about there now. Right, we'll definitely settle by that. I've got it all lined up. All I need to do is get a couple of good tacks on it, then I can put it in the best position for welding. I've decided to leave the flange that size in case you want to put a bigger throttle body on a different throttle body, and then it won't be too bad to modify. I'm going to put a little bit of treating into it just to take the chill of it, makes a big difference. Once it starts to weld, it'll be not so bad. I've got plenty of amps to play with, so. I don't take seconds playing with that. Playing with it. Put a good tack on there, I'll get one down here. camera in and try and get some decent arc shots of this being welded. And I have got the earth direct onto the filler funnel, so we don't want to give it the full benefit of all the answers I can give it. Right, that's it, finally welded. Welded, no problem at all. The secret's having it clean, a little bit of preheat. It's not a bad weld for a mechanic that pisses about. A lot of people ask us what settings I used to weld on. This is an Ortec 260 amp AC DC inverter welder. It's got 9 memories and I use memory 3 for this particular sort of aluminium welding job. I've got the main amp set at 250. I didn't use anywhere near that. AC balance set at 21%. Frequency 70 Hz. 9.1 seconds, that's post flow after I've finished welding, just to keep the tungsten cool. That's a torch I use. It's a CK20 WP20 water cooled torch, once again supplied by Ortec. It's got a different handle on it because I broke the handle and I made a new handle for it, and I quite like it. I like a nice meaty handle. I use 2.4 tungstens, gold ones for everything, and that's a number 8 gas lens. I'm going to get plenty of air in there.